أعزائي الطلبة والطالبات للصف الأول الثانوي لغات، السلام عليكم ورحمة الله وبركاته. اسمحوا لنا أن ننعي الزميل العزيز الأستاذ المخرج شريف الساعة. إن لله وإنا إليه راجعون. توفي أمس إثر حادث أليم. نتمنى له الرحمة ونتمنى لكل أسرته العزاء والصبر والسلوان، ونتمنى أيضا لكل أسرة قناة مصر التعليمية العزاء والسلوان. الآن أحبائي الطلبة والطالبات، دعنا نعود إلى دروسنا اليوم. My dear students, we are going to start a new geometrical lesson which is parallel lines and proportional parts. Let's first recognize what the lesson is. If we have here a triangle like that, and we have a straight line like that parallel to one side and intersecting the other two sides, we have the triangle ABC and a straight line XY parallel to the base BC and intersecting the other two sides AC and AB at Y and X. The sides here will be proportional as AX over XB will be equal AY over YC. That's a figure. We have many figures here. Sorry. If we have straight line like that, and we have a triangle like that, and if we expand the straight line here, and expand this line here like that, and we have the triangle ABC as before, and the same straight line XY, and XY parallel to BC, then we will have the same ratio AY, or we can start by AX as before, AX over AC equals AY over AB. Okay, and if we have another figure like that, this is a triangle also, and we expand it like that, we have here the side of the triangle, and we have here the straight line XY which parallel to BC, and this triangle ABC also, it's the same triangle as in fact. So we can say that AX over AB will be equal AY over EC, or we can say AB over BX will be equal AC over CY, so that we can use this to find the different sides if we have the others. Let's go to another triangle like that. Yes, if we have here a drawing like that, and we have a line here, or a line segment. Let's expand it a little. We have here a line segment also, and we have a line segment here. We can call them A, D, E, B, G, C, F, and DA parallel to EB parallel to CF, and we have ED equals 7 centimeter. Here GE equals 3 centimeter, and AG equals 16 centimeter. We can express it like that. GA equals 16 centimeter, and GC equals 6 centimeter here. Find the length of GF and GB. We would like to find the length of these two line segments. We can use our theorem, which we talk about today. Here we can use it to find GB first, or BA, and after that we can use these two triangles. So we have EB parallel to CF. Okay, let's first use this part, GDA. Since EB parallel to DA, therefore we can say GE over GD will be equal GB over GA. So GE over GB will be equal GE over GD, will be equal GB over GA. We can put the numbers here. Instead of GE, we can put 3, and GD will be 3 plus 7 will be 10, equals GB, we don't know it, write it as it is, over GA, which is 16. And we can find GB here by cross multiplication. 3 times 16 over 10. The answer will be 4.8 centimeters. And also we can use this part because CF parallel to EB, and we can start with this part. We can say EG over GF equal BG over GC. We have GB here equals 4.8 centimeter, and all GA equals 16. We can find out BA by subtraction. 16 minus 4.8, say 16 minus 5 will be 11, so it's be 11.2 centimeters. If you want it. Here we have EG. EG here equals 3 centimeter over GF. We don't know it. It's unknown. And GB equals 4.8 over GC equals 6 centimeter. And also we can cross multiplication it. We can multiply 3 by 6 divided by 4.8. So GF will be equal 3 times 6 over 4.8 here. And the answer will be 3.75 centimeter. Sorry. You can use your calculator to find it. Okay. Let's move to another question here. My dear students, use your theorem and try to find out the missing parts. It's already from similarity you can deduce it, and we can go to another the converse of the theorem. The converse of theorem 1. Okay, let's draw a triangle here, ABC, like that. A, B, C, and we have ED here. And it is given that AD over DB equals AE over EC. And required to prove is to prove that ED parallel to CB. Solution. We have here AD over DB as given equals AE over EC, and we would like to prove that ED is parallel to CB. From the ratio before, if we have first term, also this is the second term, this is the first term here, and this second term. We can call them antecedent and consequent, but to be easier, I'll call it first term, second term, and this is first term also, and this is second term. From the ratio properties, we can write first plus second term over first term. It will be equal from the other ratio, first term plus second term over first term. First term here is AD, plus second term will be DB over the first term, which is AD itself, will be equal from the second ratio. First term will be AE plus second term will be AC over first term, which will AE. Look carefully at this figure. AD plus DB will be equal what? Of course, AD plus DB will be equal AB over AD itself, and we have AE plus EC here will be, of course, AC over AE. AB over AD, or AB over ADS, and AC over AE, and we have here a common vertex or a common angle. From similarity, this is similar to triangles here. This triangle will be similar to the whole triangle by using side included angle and side. So the two triangles here will be similar. Okay? So we can deduce that the angle, measure angle ADE equals measure angle ABC. And as we see here, these two triangles are corresponding. So we can easily deduce that DE parallel to BC. So if we have AE over EC equals AD over DB, it's now in fact that we can deduce that DE parallel to BC, and this is the converse of the theorem 1. Okay, let's now try to use this theorem and its converse to solve another question. We have another question here. Look carefully with me. We have a drawing like that, a triangle here. Like that. This triangle called A, B, C, and we have a side like that, DE, parallel to BF, DE here, parallel to BF. AD here and DB, we don't know them about them, but we have a ratio that AD here equals 3 over 4 DB. We can write AD over DB equals 3 over 4. AD over DB equals 3 over 4 here. And we can write AD as 3x and DB as 4x. My dear students, you know that if AD over DB equals 3 over 4, it's a simplest form ratio. But we know that AD may be a number multiplied 3 as 3 times 5 can be 15, and 3 times 4 so 5 times 4, so it will be 20. And when we simplify, this ratio will be 3 over 4. So we cannot say that AD equals 3 centimeter or 3 meter if it's the ratio. We say AD equals 15 or something else multiplied by a number numerator in numerator and denominator. So we can say that it multiplied by a number x, and this one multiplied by x also. So we can say AD equals 3x and DB equals 4x also. And we have DE parallel to DF. Required to prove that DF here, it's required proof parallel to BC. I know that now they are not parallel, in fact, but we can prove them, so we can put F in this point as example. Okay, let's go on the solution. We have here AD to DB 3 to 4, so we can say 3x and 4x. And we have AE equal 4.5 centimeter and FC equals 14 centimeter. If we imitate at this figure and concentrate our eyes on DF, DE and BF, which is are parallel, so in triangle ABF we can say since DE DE here parallel to BF. So we can say that AD over DB equals AE over EF. We have here AD 3x and DB 4x, 3x over 4x equals AE, which is 4.5, and EF is unknown. We can cancel x with x here. So EF will be equal 4 multiplied by 4.5 over 3. So EF equals 6 centimeter. We can put 6 centimeter here for EF. And we will transfer to the bigger triangle ABCD, ABC. So in triangle ABC, we can say AD over DB will equal 3 over 4 as given. And here say AF over FC, AF over FC. AF here equals 4.5 plus 6, so it's 10.5 over FC, which is 14. You can use mind or you can use your calculator to find out that the answer will be 3 over 4. So we can deduce that AD over DB equals AF over FC. So AD over DB here equals AF over FC. Look carefully at this triangle. AD over DB equals AF over FC. So we can deduce that DF parallel to BC. Even the drawing is like that. Okay. We can go to another example. It's important, my dear students, that the ratio between two sides, say AB over BC, 2 over 3, that's not mean that AB equal 2 centimeter and BC equal 3 centimeter, but 2 over 3, it's simplest form for another number. Maybe multiply this number by 2, 3, 4, and so on. So concentrate with me to find out the solution of another question here. We have a triangle like that. And we have two sides. This is called D, E, A, C, B. And we have the length 2 centimeter, 3 centimeter, 9 centimeter, 6 centimeter. This is the given, these are the given, and you would like to find out or prove that or investigate here F DE parallel to BC and Y. We try to find out if DE here parallel to BC. To find out that or to prove that, we have to find a dA over AC here. dA over AC equals 2 over 6. And in simplest form, which is important for us, will be 1 over 3. So we have AD and over AC equals 1 over 3. Try to find out EA over AB here. It will be 3 over 9. In simplest form, it will be 1 over 3. So we now know that dA over AC equals the same as EA over AB. Yes, EA over AB equals dA over AC. Therefore, ED parallel to CB. And this is the reason, because this ratio equals this ratio. Okay, let's move to another question. We have many questions for you, so concentrate with us. We have this figure. We draw. Try to draw with me if you want. Like as 2 triangles here. And we have a line segment here parallel to this base, and another one parallel to this one. Okay, this is D, A, X here, B, Z, and C, and this is Y. And as we have agreed that AD parallel to X, Y, and CD is parallel to ZY. Okay, and the required to prove is prove that XZ parallel to AC. Okay, we would like to prove that XZ parallel to AC, and we have no lengths for sides, and it is needed. So concentrate with me. We will start first by the triangle DAB. Triangle DAB. We have XY parallel to AD. So we can easily deduce that BX over XA equals BY over YD. BX over XA equals BY over YD. This is one proportional, and we can deduce also from the triangle BDC. We have YZ is parallel to DC, so we can deduce that BY over YD, therefore BY over YD will be equal BZ over ZC. And we can call it the equation number 2. Look carefully at these two equations. We have a common ratio here. Yes, we have BX, yes, BY over YD. This ratio is the same as this ratio here. So we can easily deduce that BX over XA equals BZ over ZC. Look at the figure here. bx over xa here equals bz over zc. Yes, we have here zx. Okay, zx here will be ca. Therefore, zx is parallel to ca. Okay, my dear students, let's get a little break and we'll return again. Yes, my dear students, hello again. Let's go to another question here. We have another example for you. We have AD, a line segment here, and we have AB, another one. We have BC, like that. And also we have DC, and this is Y, and we have here YA equal 2.5 centimeter and YD equals 3.5 centimeter, and we have a diagonal here called AC, like that. We here call it Z, and we have ZX, and ZX will be parallel to CB. Okay, and AX equals 3 centimeter, and XB will be 4.2 centimeter. And we would like to prove what? We would like to prove that first YX parallel to BD. Where is YX? YX here. This is Y. So we join YX. We would like it to parallel BD. We can join BD also. Okay. And secondly, we would like to prove that YZ parallel to CD. Where is YZ here? Another pen to be clear for you. YZ here, this side, we can join it. Would like to prove that it's parallel to CD. So we will try to first prove that XY parallel to BD, and secondly we will try to prove that YZ parallel to DC. Let's first use our parallel, which is XZ here, parallel to BC. We have AX equals 3 centimeter and XB equal 4.2 centimeter. So in triangle ABC, we know that XZ is parallel to BC. So AX over XB will be equal AZ over ZC. So AX over XB here equals 3 over 4.2. In simplest form, we can use calculator to find out that the result will be 5 over 7. And this is number 1. We have here the ratio AZ over ZC equals 5 over 7. And AY over YD, that's in the triangle AD, in triangle ADC. YA equal YD over YD equals 2.5 over 3.5, and also equal 5 over 7. And this is number 2. Okay, we have AY over YD equal 5 over 7, and AX over XB also equal 5 over 7. So they are equal. So we can say that AZ over ZC equal AY over YD equal 5 over 7. So we can deduce easily that ZY here will be parallel to BC. Therefore, ZY parallel to CD. Okay. And don't forget that we have a ratio here, AZ over ZC equals 5 over 7. So try now to reduce that. YX parallel to DB. And we have AX over XB equals 5 over 7. And AY over YD equals the same ratio. So we can say that, therefore, XY here parallel to BC, because we have this ratio AX over XB equals AY over YD, and we have this line here, this line segment, and this line segment included. So if this one over this one equals this one over this one, so we can deduce easily that YX parallel to DB. Okay. We have also something called Thales theorem. Thales theorem, we have our scientist called Thales, so this theorem it's of for him, so we call it Thales theorem. Thales have drawn many parallel lines like that. Concentrate with me to find out what is the Thales theorem. We have some parallel lines here. Many, we can draw many parallel lines like that. And we have two straight lines, cut them. We can call this straight line L, and we can call this straight line M. And all these straight lines are parallel. And we have here parts. We can call this A, B, C, D, A dash, B dash, C dash, D dash. And theorem, the theorem of Thales was if we have something like that, so the ratio AB to BC to CD will be equal to the ratio A dash B dash to B dash C dash to C dash D dash. So the ratio between these, this one to this one to this one, will be equal the ratio of this part to this part to this part. And we can say many things else from the properties of the ratio. So we can say that AB over A dash B dash equals BC over B dash C dash and we can say that BC over CD equal B dash C dash, like that, over C dash D dash. We can play with it. And also we can, from the properties of the ratio, find the sum of the two ratios, like that. We can say AC over CD will be equal A dash C dash over C dash D dash. And also we can start from top, bottom to top, like that. We can say that DB over BA it will be equal D dash B dash over B dash A dash. Any ratio from the right side or left side, but they are the same. Try to find out the ratio to be the same. Yes, let's move to another question. We have an example to applicate by Thales theorem here. So concentrate with me. We have a drawing like that. Line segment here and another big one here and another big one there. This is big part. We have D, A, E, F, this Y, and we have this line parallel to this one, CDX, and we have also another parallel line to it. We call it BF, and we have this line segment equals, the length of this line segment equals 35 centimeter, and this is 20 centimeters and 24 centimeters here for BA and 16 centimeters for CB. And we have all of these line segments are parallel, and we would like to find the length of the line segment EF and line segment CD. So concentrate with me. We will start with the ratio AB and GF. We can say AB here over GF, which is BA over GF, will be equal BC, of course, over XF. This ratio over this ratio, this number or this line segment over this line segment sorry, will be equal BC over FX. If we have AB equal 24 and GF we don't know about its length, BC here equals 16 and XF equal 20 centimeter. So we can use cross multiplication here to find the length of GF, and GF will be equal 20 multiplied by 24 over 16, and the answer will be 30 centimeter. We can put here 30 centimeter for GF, and we can also use another issue to find CD. We can say that AB or BC over FX will be equal CD over XY, and we have BC here 16 over FX 20 equal CD, which is unknown, over XY, which is 35 centimeter, and of course we can find out the length of CD will be 15 multiplied by 35, sorry, multiplied by 16 over 20. We use cross multiplication. So CD, by using your mind or using your calculator, the answer will be 28 centimeter. And we have finished this equation, this question. Let's move to another one. We have a drawing here like that. Okay, and another one, and we have some parallel lines like that. This one and this one, and also this straight line, and we have another straight line. All of them here are parallel. We can call it XY, ZN, and these points A, B, C, and D. Here AB equals 1.4 centimeter, 1.4 centimeters, and BC equals 2.1 centimeter. And we have XZ here, XZ, all of them, XY plus YZ equals 3 centimeters. And we have ZN equal 2.4 centimeters. And we would like to find out the length of XY, the length of XY, and the length of CD, line segment CD. Our solution will be, we have AB over XY here. If we divide AB over XY, AB over XY equals what? We can say CD over ZN equals AC over what? Of course, over XZ. Why we have chosen this? Because XZ here equals 3 centimeter. And we put the numbers here like that. Okay, 2.4 equals 3.5 over 3. So by calculating and using cross multiplication, XY will be 1.2 centimeters and CD will be 2.8 centimeters. And we have finished the solution of this question. My dear students, I am pleased to meet you today. And again, نحمل كل مشاعر العزاء للزميل العزيز أستاذ أشرف الساعة. نتمنى للفقيد كل الرحمة، ونتمنى لكل الأسر، أسرة البرنامج وأسرة التلفزيون وأسرة قناة مصر التعليمية وأسرته الخاصة كل العزاء. السلام عليكم ورحمة الله وبركاته.